Assalamualaikum and a very good morning to our lecturer, Dr. Razana, and my fellow classmates. We are from Group 4 and today we are presenting our title, Matrix Acidizing. Hello, my name is Nurul Hazika and my other group mate, Madihi, and my other group mate, Siti Nur Hananiza. In section 1, I'll be introducing you guys to formation damage. So what are formation damage? In the petroleum production, formation damage is one of the challenges that they faced near the wellbore. Fouling situation, just like formation damage, decreases the reservoir's productivity. This fouling situation is treated by acid treatment jobs. Situations such as drilling, perforating, production, chemical treatments is also known as fouling situation. In carbonate reservoir, conventional matrix acidizing is used to remove and stimulate the well performance by using HCl, also known as hydrochloric acid. This conventional matrix acidizing produces wormholes. Wormholes. Wormholes, what are they? Wormholes are small holes that is generated by the matrix acidizing treatments. So, the injection of reactive fluid takes place in the deepest part of the wellbore. Wormholes are a favorable pathway because the more wormholes there are, the better the reservoir's permeability is. Developing wormholes is highly affected by acid types and rate of injection. So I'm showing you guys a visual. On the left side, which is A, shows that that is a wellbore before the acidizing treatment. As for the B side, which is on the right side, shows an after acidizing treatment. There is a blue pathway that is created until the deepest part of the wellbore. So the aim of this matrix acidizing is to explore matrix acidizing in a carbonate reservoir and to find out the acidizing stimulation and matrix acidizing that is available for a carbonate reservoir. I'll be passing this to my other group mate, Hanani.
Hi, so I will explain more on the section 2, which is the wellbore stimulation. In the wellbore stimulation, we have different kinds of many matrix acidizing. The first one is matrix acidizing. So what is matrix acidizing? Matrix acidizing is a process that we use to stimulate the well, either to improve or to remove the damage of the well. At the same time, matrix acidizing also we use to decrease a skin factor in the carbonate reservoir. The process of matrix acidizing also to create the wormhole by injecting the acid under the formation pressure. And in the matrix acidizing that occur in the carbonate reservoir, the propagation of wormhole is depend on the chemistry and the treatment of the matrix acidizing, such as volume and injection of acid. Last but not least, in matrix acidizing, the accurate acid placement are important in the carbonate reservoir, which the result is when the permeability of the carbonate reservoir high, so the acid will flow smoothly. Okay, so I will explain about the fracture acidizing. So what is fracture acidizing? Fracture is acidizing is a pneumatic treatment for carbonate fracturing formation in which acid each serve in great conductivity flow routes with the fracture. In fracture acidizing, the method that always used is low native permeability. Acid fracturing always generate long wormhole and engraved line pathway on fracture face in carbonate reservoir. So there are three types of fracture acidizing, which is pre-flush acid and overflush. So what is pre-flush? Pre-flush is we apply to reduce the temperature in a large fracture with long gap. So for the acid, we use a simple acid to react with the carbonate reservoir. So the reaction will be rapid and dissolve the rock will be large. So the last one is overflush. So what is overflush? Overflush is used to moving the volume of the acid forward. So for the wellbore clean out, I will let Hazika to explain more about it.
So I'll be explaining for the third matrix acidizing kinds. Wellbore clean out. Wellbore clean out is also known as pickling treatment, which is a critical intermediate phase in most achieved simulations. It is often used to remove corroded iron, deposition of irons and scales, to ensure the injection do not deteriorate the reservoir's permeability. There is a solution that circulates inside the wellbore, which contains 10 to 15% of HCl, and the flow that is circulating is up to 2,000 to 3,000 gallons of HCl. The normal solutions contain HCl, or might as well acetic acid, which is toxic. Coiled tubing is used in wellbore clean out. This coiled tubing easily spreads the acid through the operating line, which goes up and down. Acid use will go up to the surface via annulus.
So I will explain about the acid used in the wellbore stimulation of matrix acidizing. So the first acid we use is hydrochloric. Why we use hydrochloric? Hydrochloric because hydrochloric is used to clean the tubing, low corrosivity, low cost, and also used to remove the damage zone and skin effect. However, there are two disadvantages of using hydrochloric. What is it? The first one is the high reaction rate with the carbonate will limit, and the second one is hydrochloric have high corrosivity in the well tubing. The second acid we use is hydrochlorofluoric and hydrochloric. Why? Because both of these acids are good to treat the carbonate stimulation. The last one acid we use is organic acid. Why? Because organic acid is low corrosivity, easy to inhibition, good to protect the surface. In the organic acid, we got 4 types. The first one is corrosion inhibitor, the tension active, ion control, and organic acid. The first type is corrosion inhibitor, which is to protect the drain pipe. The second one is the tension active, is to reduce the surface and enhance the acid rock. The third one is ion control, to generate from corrosion to form a surface. And the last one is organic acid addition, which to form the relative low permeability of the filter cake in the carbonate reservoir. Thank you.
So I will explain section 3 in this topic, which are the metrics, acidizing, and carbonate formation. In this topic, there will be the estimation for acid volume and the optimum rate of injection speed. So to estimate the acid volume, there are two models that can be used, which are Descartes model and volumetric model. So in Descartes model, the equation is shown in the screen. So in the Descartes model, the V over H, which is the estimation of volume acid, will be equal to the Weber radius times with the pi, then times with the porosity of the formation, and then it will be times with the acid rate per unit thickness of the formation, which is D, and then the D will be to the power of 2 over 3 and times with the Q over H, which is to the power of 1 over 3. After that, it will be divided by the acid capacity number times with the constant of the equation. So for volumetric model, the equation is shown at the screen, which is V over H equal to the pi times with the porosity, and then times with the fraction of the rock that dissolved by the acid, and then it will be multiplied with the penetrated well-bore radius, and with power of 2 minus with the well-bore radius with the power of 2, and then it will be divided by the acid capacity number. Both of the models will use the acid capacity number to get the result. So for section 3.3, which is the optimum rate of the rate of injection speed, will affect the wormhole morphology, which is the creation of wormhole and the dissolve of the rock in the formation. So at low injection speed, the whole volume of acid are used before entering the medium, and then the breakdown of formation will occur. At the high rate injection speed, the penetration of the acid into the formation rock is deeper, but it is slower because the surface that needed to be covered is because it is larger. So because of the speed of the injection, so we will use the optimum rate, which is where the wormhole will be created and wormhole propagation will be occur. Because for the wormhole to be for the metal acidizing treatment to be working, wormhole must be created. So in conclusion, the rate of injection speed will affect the wormhole creation and the dissolve of rock. So in conclusion, the rate of injection speed will affect the wormhole creation and the dissolve of rock formation. Besides that, the metric acidizing treatment are commonly used in the world because it is quite inexpensive. Other than that, even though there are major problems occur when using this treatment, but due to the modern technology, the problem has been solved. So that's all from us. Thank you.
These are the references used in our research. Thank you.